Okay, we're on the Chapter 2 review for Algebra 2, and these are examples, problems 30 and 31 to start out here. And we're simply supposed to describe the translation that's happening here. So I'm actually going to change this problem. I'm going to put a negative in front there so you have more examples here. The first, hang on, oh, it's not included in the list, so cancel that. Let's go with absolute value of x plus 5. When it's outside of the absolute value, you'll get an up and down motion, and you can trust the sign. So this one is going up 5. The inside translations are not trustworthy, and they do go left or right. So this one is left 3 units, and the other one is down 2 units. The outside is up and down, and you can trust the sign, so negative goes down. But the inside is left and right, and there you better not trust the sign because it goes the opposite way. Okay, we're supposed to write down the equation or the inequality that would yield this. This is just a linear equation. It has a y-intercept of 4. And if you go to that first intersection there of the grid, you can see it goes down 2 spaces and 3 to the right. So the slope is negative 2/3, and you just write it in y equals mx plus b format. So it's going to be y equals negative 2/3 for the slope plus 4 for the y-intercept. Okay, the next one here is a v, and it's an upside down v. So I'm going to put a negative in front of an absolute value sign. Now it looks like the original would have been centered right there, right side up, but centered right there. And it goes 4 to the left, and then 2 units up. And there we have it. The slope of the right arm is negative 1, so that's really like having a negative 1 there and a 1 there. This moves it to the left 4, and this moves it up 2. And the negative 1 in front, or the negative sign in front, makes it point downwards, open downwards. Okay, number 34, and then we'll finish off with one more, number 35. This is a linear equation, and you can probably see that its y-intercept is 2. And it looks like if we slide down to the next intersection, that's down 3 and over 4, so negative 3/4 is our slope. So you would normally, for the border, you would write it this way. But we are trying to shade above this, and we want a dashed border, and that combination goes with greater than. You can see it's shaded above and dashed. Okay, one more like this. This time it's a V-shaped graph. And what we have here is a vertex is 2 to the right and 6 down. So we have a right side up V. I'll do the border first. Right side up V, that's 2 to the right and 6 down. Now we have to make sure this is a solid shading. You need the or equal to and above. So that's why I put the greater than or equal to. And there we have it. There is the equation or the inequality that describes this shaded region right here, where it's shaded above the V. And that does it for us all the way through example 35.